Okay, this is 8.4 D as in dog, trigonometry, continuing on with our examples. I'm going to do example 2, and what they're asking us to do is find the two square roots of 4i. So we're going to take the square root of that, and when we take the square root of that, we get two answers. Alright, so first of all, we need to rewrite this in trig form, because that's the only way we know how to do this. So that's 4 cosine, and we're going to do radian. So instead of a 90-degree angle, we're going to write it as pi over 2. And again, this is old stuff, so I'm not going to show you how to do that. Alright, so here we have r equals 4, and we have theta equals pi over 2. And there just appeared that chart on the bottom of page 354, and what we're going to do is we're going to look at this right there. Okay, because remember, this one is degrees, this one is radians. Those are the only two you really have to look at. Alright, so let's move this chart out of the way so we can just see what we need here. And I'll put it right up here, because all we need, again, is this part right there. Alright, because we're given the r, and we're given the theta is pi over 2. Oh, and we're also given n. We said we're going to find the square root, so our n is going to be the number 2 there. Alright, so now that we have this written in trig form, we can go ahead and get started. Okay, so if our r is 2, we know from, I got to pull this chart here down. Let's expand it just so you can see it. If our r is 2, or our r is 4, and we're taking the square root because our n is 2, we know that this part of the problem is going to be the square root of 4. So let's go ahead and just put 2 down for that part of it, because that is not going to change no matter what we do. Alright, so let's move that back to where it should be there. So again, the square root has an absolute value of 2, so we know we're gonna have 2 in our answer there as that first part, and then we're gonna have this here in order to find our angle, our alpha, what the square root of theta is. Alright, so let's write that. Alpha equals, I'm just taking it from here, right there, equals theta over n, which we said n was 2, plus 2 pi over, again, n, times our k. Okay, so k is going to be 0. It always starts at 0, and it's going to be 1. And that's all the further we're going, because our n is 2, so we only write it twice. So we're going to write that with a 0, and we're going to write pi over 2, pi over 2 over 2 plus 2 pi times our next one over 2. So those are our two alphas. So when we plug those in, we get pi over 2 divided by 2 would be pi over 4, plus, this is just going to give me 0, because anything multiplied by 0 cancels it all out. So this is actually just going to be pi over 4, which is what we got right here. Okay, this is going to be pi over 4 plus 2 pi times 1 over 2. Those cancel, and we end up with pi over 4 plus pi, so we find common denominators. So we have 5 pi over 4. So that's one of my alphas. That's my other alpha. Alright, we already found out that the root of my r, the square root of my 4, was 2, so I have 2 cis pi over 4, and I have 2 cis 5 pi over 4 from here and here. And those are my answers. Now I need to convert them to rectangular form. And I'll leave the converting to rectangular form to you, because that should not be that hard, because a pi over 4 is a 45-degree angle, and a 5 pi over 4 would be 5 times a 45-degree angle, whatever that happens to be. 220 degrees. So those are your two angles, 45 and a 220-degree angle. Or if I quit multiplying in my head and get 220 degrees, I would have gotten 225 degrees. I don't know why I thought 45 times 5 was going to give me a 220. Should be 225-degree angle there. Okay, so anyway, you can finish converting that into rectangular form. Remember, rectangular form is the x plus yi format. Alright, so anyway, that is example 2. Let's jump to example 4, and then we'll call it a day. Okay, this one is an equation. The other ones weren't equations at all. We were just taking the roots of a number, per se. This time we're giving you an entire equation, and I'm asking for the complex number solutions. I'm asking for the answers that when we take a number times itself 5 times, subtract 1 from it, we're going to get 0. Well, I know then, whatever that is, x is going to be 1, right? Or yeah, because x to the 5th equals 1. And if I take the 5th root of that and the 5th root of that, I'm going to get 1. Alright, so anyway, I am looking for not necessarily the real number solutions, because the real number solution says that I'm going to get 1 for an answer. Well, there's also some complex number solutions, some imaginary number solutions, I know, that make this true. And I know that there are 5 of them because of this number right there of the 5. So what I'm looking for is my 5 complex number solutions that are going to make this true. So even though there's only one real number solution, which is 1, there are also 5 complex solutions. So what we're going to do is we are going to write the number 1 in trigonometric form. So 1 equals 1 plus 0i. Okay, so that's the complex form. And then I go ahead and take this and write it in trig form. 1 cosine of 0 degrees plus I sine of 0 degrees. Okay? So the absolute value of the 5th root is 1. Okay, so I've got my first part of it. Okay, so because this is my r, and let's see, this here has to be on there. 5th root of 1 is 1. So I know this part of the problem is done. That is going to be a 1. Now I'm going to have to find this one. So I'm going to use this formula to find my alpha. Alright, so let's go ahead and do that. Alright, so here are my 5 k's, and I'm going to put it in this format here because I'm dealing with degrees. So I've got 0 over n, and what is my n? My n is 5. And then I'm going to add 360 times k, which is 0, over 5, and that gives me 0. Next one I'm going to do is going to be 0 over 5 plus 360 times 1 over 5, and 360 divided by 5 is 72. And then I'm going to do the same here. Really, those are all going to be zeros. So 360 times 2 is 720. 720 divided by 5 is going to give me 720 divided by 144. When I do the 3, I get 0 over 5 plus 360 times 3. And that's going to be divided by 5, and that's going to be 216. And then 0 over 5 plus 360 I know this gets a little monotonous. Divided by 5 is going to be 288 degrees. So there are the degrees, the alphas, for my 5 answers there, when k is 0, 1, 2, 3, and 4. So I get, for my answer, in this form, I get 1 cis 0, 1 cis 72, 1 cis 144, 1 cis 216, 1 cis 288. And again, I can get rid of all my 1's here, and I end up with those for my answer. And if you spread those out, again, of course, you're going to get cosine 72 plus I sine 72. You know, you're going to do that for each one of them if you wanted to expand that out. So, anyway, that is it as far as leaving them in trig form. So when the book asks you to do these on 13 through 23, go ahead and leave them in trig form like this here. You don't have to convert them back to rectangular form. The answer key just leaves them in that trig form there. So I'm going to do one from 8.4 problem set in the next video, so hopefully that'll help you a little bit.